Hello, everybody, and welcome to today's Dynamics 365 Tech Talk. Today's topic is Demand-Driven Material Requirements Planning in Dynamics 365 Supply Chain Management. My name is Peggy, and I'll be your moderator today. We're broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. All registrants will receive a link to the recording as soon as it is available on the Tech Talks Community Dynamics page. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions at the end of today's presentation, so we thank you for your patience. Presenting for us today from Microsoft, we have Anne Krupe, Senior Fast Track Solution Architect, and Beatrice Gracia, Program Manager 2. Anne, over to you.
Thanks, Peggy. Good morning, good afternoon, or good evening, wherever you're joining us from. We're very excited to get started today with our discussion on demand-driven material requirements planning for Dynamics 365 supply chain management. Let's start with a quick round of introductions. Beatrice, let's have you go first.
Hi, I'm Beatrice Gracia, Product Manager on the SCM product group, responsible, among others, for the DDMRP functionality and planning optimization. And now, back to Anne.
Thanks, Beatrice. I'm Anne Krupke. I am a Senior Solution Architect on the Fast Track team here at Microsoft, responsible for helping customers with our implementations, especially in the planning and manufacturing areas. Before we dive into this topic, we want to take a minute to pause and note that DDMRP functionality, which is short for Demand-Driven Material Requirements Planning, is a big new feature to Dynamics, and in this session, we consider it to be DDMRP 101, the very basic introduction. How do you get started with Dynamics? But we do plan to add additional sessions upcoming to talk about specific use cases in manufacturing, distribution, and retail for DDMRP, as well as if there is interest in having a live Q&A session where we just spend an hour answering any questions that you may have on DDMRP. So please do let us know in the chat what your feedback, or in the survey, what sessions would be useful to understand more about this functionality and whether you would be interested in a live Q&A on this new functionality. To keep things interesting, we have a riddle of the day. The riddle is, how do you organize a party in space? Feel free to put your answers in the chat and we'll reveal the answer at the end of this session. Our agenda for today's session, again, is DDMRP 101. So we'll start with what is DDMRP, and then we'll talk about the 5 components of the DDMRP process and how those relate to the configurations that we'll need to set up in Dynamics to support DDMRP. We'll do some light demonstrations of the functionality that comes with this new feature set, and then we'll cover some recommendations and resources for getting started with this functionality. With any of the time that we have left at the end, we'll answer your questions that you can put in the chat throughout the presentation.
Let's start by understanding what is DDMRP. So far, companies have been using MRP, but in the last years, supply chains have changed. There are many parts that come from overseas, having long lead times. Many companies reported suffering stockouts or overstocks, not knowing how much to stock. There's higher market fluctuation with more variability, sometimes not accurate forecasts, and customers demanding products with a short lead time. There are also supply chain shortages all over the world. And on top of that, MRP tools many times tell you as a planner thousands of actions to do, so you do not know what to focus on. In this context is where DDMRP appears. DDMRP, shortening for demand-driven material requirements planning, is a formal planning and execution method to protect and promote flow through the establishment of strategically placed decoupling point buffers. That means in some specific points of your supply chain, you're going to place an inventory buffer that you will replenish and control. And it has proven to help with all these problems. The knowledge center for the DDMRP methodology is the Demand-Driven Institute, and Dynamics is compliant with it. At the end of the presentation, you'll find a link to their website that you can always use to learn more about DDMRP. Now let's see the 5 steps or processes of DDMRP. First one is strategic inventory positioning. It is where you will identify which points in your supply chain will be the decoupling points, where you will place stock buffers. Second is buffer levels. It is the process of calculating how much stock should be, which levels. Third is dynamic adjustments. It is where you adjust those buffer levels based on market changes or other factors. Fourth is the demand-driven planning. It is the process itself of creating planned orders for replenishing the buffers, and also of all those planned orders, giving them a priority. And last, visible and collaborative execution. It is the process of executing those orders. And you'll see that DDMRP is a very visual tool. When we talk about types of ways you can use DDMRP, we often think of examples that are relevant to manufacturers who have a multi-level bill of material. But that is not the only application of DDMRP principles. You can also apply this theory and the functionality to support distribution and retail networks. And we will make sure to highlight these use cases, especially in the future sessions that we have planned. Before we dive in, let's go through some key information about the functionality that is released in Dynamics to support DDMRP. Firstly, the functionality has been added to our existing master planning module. It is integrated with the existing planning setups, and it is used together with it in order to arrive at the right configuration for your business. Ultimately, DDMRP is controlled by a new coverage code in Dynamics. It is completely different from period, min-max, requirement, etc. In summary, it is not a new module, and it does not replace what we currently have, but it gives you more functionality to use. DDMRP functionality has been released in version 10.0.28, which will be available for manual update on July 1st. The reason why it's preview is because we would really like your feedback. And for us, it's much easier to change anything while being on preview. The code and the UI are totally GA quality. If you're going to uptake it or have any feedback, please post on the planning optimization group on Yammer that we will be monitoring. And to use it, you just have to enable the feature that is here on the slide. There are additional pieces coming in version 29, which will be the average daily usage forward and blended, and a new form for the decoupled lead time. It is also only compatible with the planning optimization service, so it does not work with the classic master planning. And finally, the functionality is included in the base licensing for Dynamics SCM. It does not require any additional cost to use.
So now that we've covered what DDMRP is and those core 5 components, let's dig into the first component, which is strategic inventory positioning. Strategic inventory positioning involves identifying points in our supply chain where we can build up inventory on hand. We do this for a few reasons, mainly for lead time compression and shock absorption in our supply chain. This lets us mitigate the bullwhip effect by not passing demand variability all the way down the supply chain. Let's take a look at the pictured example of a multi-level BOM for our pillow product and think about how we can strategically place inventory at what we call decoupling points within our supply chain. On the right of this slide, we can see the various considerations we take into account when choosing what our decoupling points are. We will place our first decoupling point on our foam billet item, which we've represented the decoupling point with this yellow boxes icon. And we'll place it there for 2 main reasons. One, that sourcing the materials used to make the billet is difficult and volatile in the current supply chain. And because foam products or foam billets are then cut into many different shapes and sizes of foam inserts for our products. So this part meets the qualifications for external variability and inventory leverage and flexibility. Our next decoupling point will be the fabric kit, which is pre-cut pillow fabric to be used in the final assembly. We chose this one because we only have one automatic fabric cutting machine in our facility, and therefore it qualifies as critical operation protection by creating a buffer of our fabric kits. Our next decoupling point is the finished good. We are choosing to set this as a decoupling point, firstly, because our customers have a very low tolerance time when we sell our pillows. Secondly, because our sales order visibility horizon is only a couple of days, if that, and we want to ensure that we have the inventory on hand when orders are placed in the system. We are also able to set a higher price when we can keep the lead time as short as 1 day or same day, which is what market potential lead time refers to, the ability to charge a higher price for a shorter lead time. Let's use this same pillow example to understand how the decoupling points we added can help us compress the lead time. Looking at the gray boxes in the top left corner for each of our items, we can see what the sourcing or production lead time is in our multi-level BOM for each component. Highlighting in red the long tent in the pole that drives the cumulative lead time for the item, which is 21 days if we have no buffers and no inventory on hand of any of our components. But if we apply the decoupling points that we showed in our previous example, we can see that our lead time for the pillow would change from 21 days to 5 days. The 3 days to produce the pillow and 2 days to source the thread, since we will already have our fabric kit on hand and it only takes 1 day to produce the foam insert. This 5-day lead time is what we referred to as a decoupled lead time. Another way we can look at strategic inventory positioning and buffer levels is not just looking at which items in a BOM we should stock on hand, but also which locations in a distribution network, for example. In this example, we have a distribution center in Seattle and stores in Boston, Atlanta, and Portland that sell blankets from our company. If I decide that the transfer time between the distribution center and the stores is too long for my customer tolerance time, since most customers expect the product to be in stock when they visit our store, in this case, I would set up a decoupling point for my blanket item at each of the 3 stores, and each one would get a different buffer level or a stock level based on that store's lead times, demand patterns, and other factors that we'll cover in the next few slides. When we want to get a full picture of a decoupled lead time, especially with a multi-level BOM, we have a form that's coming in 10.0.29 called the decoupled lead time form that lets us view the bill of material and its components, each of their lead times, and which ones of the items in the multi-level BOM are decoupling points, which are the items that are highlighted with bold.
So once we have identified our key items that we will strategically stock, the decoupling points, the next question is, how much should we stock? This is exactly the second step of DDMRP. Each stock buffer will have a minimum quantity, a reorder point, and a maximum quantity. And with this, the buffer is defined by having 3 zones. The red zone is from 0 up to the minimum. And the minimum is also called the top of red. The yellow zone is between the minimum and the reorder point. And the reorder point is also called many times top of yellow. And green zone is between the reorder point and the maximum, which is also called top of green, the maximum. What should each buffer zone be then? The buffer zones, the red, the yellow, and the green, are calculated by the equation shown on this slide. Let's take a look at some of the concepts here first, and then we will go through an example. The first concept is the average daily usage. That is, how much of the item was used on average on a day, looking at a certain number of days in the past. In this example, if today is the morning or the beginning of the 11th of June, and we establish a past period of 3 days, the average daily usage is the sum of the usage of the item in the last 3 days. So the 8th, the 9th, and the 10th, which is 21. Now, let's say it's a new product, so we don't have any usage, any transactions in the past. Then we could use the average daily usage forward. That would look into the future, into the forecasted demand. For example, in this case, it could look 3 days into the future, and we would get that looking at the forecast, it's a slightly higher value. And finally, if we wanted a combination of both, we could use the blended average daily usage, which looks past and forward. And it is used to smoothen between those values. Then, there are 2 factors in the setup of our buffers that can be used to define how big the red and the green zones should be. The first factor is the lead time factor. The value ranges from 0 to 1, and the guidance is that the longer the lead time is, the lower the value should be. And the ranges presented here are the ranges that the Demand-Driven Institute recommends. In our pillow example, we have a medium lead time, and we will use 0.5 as our lead time factor. The second factor is the variability factor. The values, once again, range from 0 to 1. And the guidance is that products that have a higher variability should get a higher value for this factor. And here again, you can see the recommended values for low, medium, and high variability. Our example product has pretty high demand variability, so we will set the variability factor at 0.8.
Now let's go through an example of calculating the buffer zones based on the factors that we just talked about. We'll start with the yellow zone because it's the simplest. The equation for yellow is average daily usage times the decoupled lead time. In other terms, this amount is the expected consumption of inventory during the replenishment lead time for that item. Using the data we showed in our example, we have an average daily usage of 23 eaches and a lead time of 5 days. Multiplying those together, we get a yellow zone amount of 115 eaches. Now let's do the red zone. The red zone is made up of 2 parts, the red base and the red safety. The red base is average daily usage times decoupled lead time times the lead time factor. Then we have the red safety component, which is the red base times the variability factor, which allows us to pad our red zone amount for items that have a higher demand variability. You'll notice that the red base equation is related to the yellow zone, the average daily usage times the decoupled lead time. Looking again at the same example data we just used, we'll add our lead time factor of 0.5 and our variability factor of 0.8. To use this to calculate our red base will be 23 times 5 times 0.5, which comes out to 57.5 eaches for the red base. Our red safety will be that 57.5 for the red base times the variability factor of 0.8, which gives us 46 eaches. Then we will sum these two together to get the red zone value of 103.5 eaches, which will be rounded by the system to 104 units since we count in whole numbers for our eaches. You'll notice that the red base also had a decimal point, but the system will get the final red zone calculation and then round to the nearest integer. And then finally, we'll calculate the green zone, which is the max of our 3 options: the item's minimum order quantity, the average daily usage times the order cycle, or the average daily usage times the decoupled lead time times the lead time factor. Once again, part of this equation is also based on the yellow zone equation. If we look at our data for the pillow when we calculate the green zone, we'll assume that there's no order cycle, which means we don't have any time constraints around how frequently we order, and we'll use our minimum order quantity of 10 eaches. So our first option for what the green zone could be would be the minimum order quantity, which, as we just said, would be 10 eaches. Our second option is the 23 eaches of the average daily usage times the order cycle, which is 0. So this option would result in a green zone of 0. And our third option is to take the yellow zone times the lead time factor, which gives us a result of 57.5 eaches. That is the highest of our 3 options, so that's what we'll use for our green zone, and it'll be rounded to 58 eaches, just like we mentioned, that we round to the nearest because our eaches are in whole units. So taking all of those 3 zone calculations, our red zone is 104 eaches, and our minimum will also be 104. Our yellow zone is 115 eaches, which gives us a reorder point of 219. And our green zone is 58 eaches, which gives us a maximum quantity of 277. To set up this model of decoupling points and dynamics, the first thing we need to do is create a new type of coverage group, or in some cases, multiple coverage groups. Here we can see a screenshot of the one I used in our demo. We set our coverage code as decoupling point, which is a new addition with DDMRP, and we'll have some additional DDMRP parameters that are defined on the bottom right here. We define our lead time and variability factor on the coverage group, although we can override on the item level in our item coverage. We also define the average daily usage past period. So how many days in the past do we consider in our average daily usage calculation? Our guidance on that is typically enough days to have a significant factor, but not so many days that the data is not relevant anymore. For example, 2 years of average daily usage probably isn't going to give you very accurate to what your current average daily usage is, but 2 days is probably not enough to get a good average that mitigates some of the fluctuation day to day. And then finally, on the coverage group, we can set what the min, max, and reorder point period is, which is basically over what periods of time do we want to adjust our buffer levels. And our options are weekly or daily, and in this case, we chose weekly. Now let's move over to the system to show how we set the item up with a decoupling point using the same example that we walked through in PowerPoint. We'll start in the system going to the release product record for the item we want to set up a decoupling point on. You'll notice we're going to leave the coverage group on the item level blank because decoupling points are not just for an item, but at a specific location. So we can only set the decoupling coverage group on items at the item coverage level and not at the main level. In this case, we're going to set our decoupling point as item coverage on Site 10, Warehouse 101. On the General tab, we'll need to say use specific settings, and then we'll select the coverage group that I made with my decoupling point type. And then over here, I could choose to set my minimum reorder and maximum manually, but I want to use the calculations by the system, so I'm going to set buffer values over time equal to yes. From there, we can choose to calculate our buffer values. You'll notice at the top we have new functions for calculating our decoupled lead time, our average daily usage, and our minimum, maximum, and reorder point quantities. So I can do that for a specific item coverage record or in a group by clicking calculate buffer values in the master planning module. I can choose which calculations, whether I want to accept them and which items to run them on, and then click OK. Once that's done, let's go back to our item coverage and see the results of the calculation. We can view the min, max, and reorder levels for our buffers by going to the buffer values tab in item coverage. So for the next week, we have our minimum, reorder point, and maximum that we went through the calculations for in PowerPoint. We can see the average daily usage and decoupled lead time that was calculated as well. So this is the view that we have of the buffer values, and we'll see how they are adjusted over time in the next section.
Once we have the buffer values calculated, the next possible step doesn't need to be performed is doing dynamic adjustments. That is flexing up or down the buffer zones based on market changes or future events. Let's go directly into a demo of seeing how to adjust the buffer. In the Buffer Values tab, this is, again, the item with more data. You see the periods for which you have the different buffer values. Remember, these are values calculated by the system according to the equations we have shown before. But we also have the ability to manipulate the buffer levels by using a demand adjustment factor. This factor will multiply the average daily usage in all calculations. So this way you can modify the buffer zones. For example, our pillow may be more demanded in August as people head to vacation. We expect sales to be higher, so I could change my demand adjustment factor to 1.5 for all the weeks in August. Once I do that, I can select all those weeks and update my calculations. And I can see that they are adjusted based on the demand adjustment factor that I included. In this way, we can look out over time and set buffer values and then adjust based on more information that the system has, like seasonality. The calculated fields are for you to review the values and accept them. And with a full DDMRP implementation, you would calculate values every day with a batch job directly accept the values, and then view the planned orders every day for the buffers.
So now that we've gone through the configurations of our minimum, maximum, and reorder point levels at our decoupling points, let's talk about how we can generate planned orders in this model. The two main things we want to focus on are when will master planning generate a planned order and how much will the order be generated for. We're going to use the same example that we've been using throughout. With DDMRP, the trigger for a new planned order occurs when the net flow is below the reorder point level for that decoupling point when you run master planning. As Beatrice mentioned, when you use DDMRP, we expect that planning is run on a daily basis. So you're essentially checking your inventory levels once a day to determine whether it needs to be replenished. You can see the equation on the bottom of the screen, which shows how we calculate net flow. It's the on-hand inventory plus on order, that is any supply orders that have not yet arrived, minus what we determine to be qualified demand. We'll explain more what qualified demand is in detail on the next slide. But again, the trigger for a new order is when the net flow is below the reorder point on a given day. When the order is triggered, the quantity of the order, the planned order, will be the maximum inventory level minus the net flow that was calculated, as we've indicated on the graphic. We're also going to incorporate priority-based planning functionality to assign an order priority to drive our fulfillment of inventory instead of using requirement dates as we do with more of our traditional master planning coverage codes. In this case, the percent of maximum is going to be calculated as the net flow divided by the maximum quantity, which in this example is 53%. So the order priority for this planned order would be 53, where 0 is the highest priority and 100 is the lowest. So let's go back to what do we mean when we say qualified demand? So net flow is on hand plus on order minus qualified demand. The equation for qualified demand is demand past due, anything left over, plus today's demand, plus any qualified order spikes. If we look at the chart on the bottom left, in this example, we'll just assume today is June 12th, and we can see our demand for today and the next 3 days. With DDMRP, we can set an order spike threshold to identify what a demand level would be that exceeds our normal expectations for a given day. So our order spike threshold looks at the total demand for all orders on a single day, and if it's above the threshold, then we mark that day as a spike in demand. So when I calculate the qualified demand for this example, we're going to assume there's no demand past due, so we'll use 0 there. We'll incorporate today's demand, which is 18 eaches, and then the 2 orders that qualified as spikes, the 29 and the 26, and get a qualified demand of 73. You'll notice that even though we have demand for June 15th, we're not using it in our current net flow calculation because DDMRP is different in that way from traditional planning coverage groups. And another reminder, just as we said already, that DDMRP is typically run daily. So it's not that we'll never consider that demand. It's just if today is June 12th, we only consider today and then only the future dates that already qualify as order spikes. Now let's move over and really quickly review how this looks in the system. We're going to walk through the exact same example, and we'll start by reviewing the net requirements to show you the demand that we have set up. We have 220 units of on-hand inventory. Our reorder point level was 219. We have 18 units for today, 29, 26, and 20 units of demand for the next 3 days. The 2 dates that have demand over our order threshold spike threshold have a spike is yes flag on the net requirement. So to find out whether or not we'll get a planned order, we're going to run master planning for this item, although, as you know, we typically run master planning for many items at once, but we're just looking at this one example. So the system will generate a planned order if the net flow is below the reorder point, which was, as I said, 219 eaches. Since our net flow is projected to be below that, we get a planned purchase order, which was the maximum quantity minus the net flow, resulting in an order quantity of 130 units. The net flow divided by the maximum gives us this planning priority that we see over on the right of 53.07, which we can use when we're looking at all of our different locations where we might stock this item and trying to prioritize the flow of inventory.
And finally, the last step of DDMRP is to execute on those planned orders to replenish the buffers. So let's start by seeing a buffer and how is the on hand of it. So we've seen how the buffer for the pillow was replenished, but from an execution perspective, it's important to see the actual on hand. From the item coverage form on the on hand tab, we can see its current value. And if we had historical data, we could see how the on hand progressed over time. We can also see if it is critically low, less than half of the minimum, low, between half of the minimum and the minimum, average if it's between the minimum plus the green zone, or higher, as it is our case. Note that the on-hand colors are different than the colors we saw before on the value. And the on-hand is recorded for a specific period every time planning optimization is run. To give you an idea of how the on-hand would look over time if we had past data, I'll show you the item B002, the fabric kit, that was also a decoupling point. Then, as you can see as well, you have the values of the on-hand over time. You can visually see how the on-hand went over time compared to how it was supposed to be in the green. And then in the buffer values, if you had data over time as well, you will see how they change over time. You will see the on-hand as well here and the net flow. Now we've seen for a decoupling point. But what if you had many? How do you get that overview? So in our pillow example, we had two other decoupling points. Let's go back to the demo to see how you would see them. So let's go to the navigation pane, master planning, and you see that there's a new section, DDMRP, where you have the decoupling point status by net flow and on hand. On the net flow, it's the planner workbench, where the planner is going to be able to see all decoupling points, as well as all the components of the net flow: on hand, on order, and qualified demand. If we select one, we can see the planned orders and we could firm it from there. On the execution side, we're interested in seeing the actual on hand of the buffers. So as well, we're able to see the components of the net flow. And finally, you can see an overview of all your decoupling points on the dashboard by net flow, where we have, again, our 3 buffer zones and how many items are on those, and on hand and how many decoupling points are there. Planned orders for decoupling points how many planned orders are for buffers whose net flow is below the minimum, and then how many have the net flow between the minimum and the reorder. And you'll see the planned orders there as well. This was the last step of DDMRP. So then let's wrap up.
Let's talk about resources and guidance to help you get started on your journey with DDMRP. This is just, again, a recap of what we showed, the different components and how we do each of them in Dynamics. These are the benefits of DDMRP as explained by the Demand-Driven Institute: improving your on-time fill rate, reducing your overall lead times, right-sizing your inventory, reducing the cost associated with expedition of orders or last-minute fulfillments, and improving the usage of master planning tools by letting you see that priorities and identify the important messages to pay attention to. To get started using this functionality in Dynamics, we don't recommend that you go turn this on for everything, because it could be a very big change in how you stock inventory. So one, you could end up with a lot more inventory on hand, which has a financial impact. It also has an impact in terms of overall storage capacity. So the first thing that we recommend in your journey is that you understand more deeply the DDMRP concepts that we covered on a high level today, because it truly is a methodology, and we have added functionality in a system that supports this methodology, but it's really important to understand why we're doing it this way. The Demand-Driven Institute has resources that you can access online, as well as a training course that they provide so you can become a demand-driven planner certified by them. There's also a textbook for DDMRP, which you can either get virtually or order the actual textbook in print if you're interested to have the full content. From a Microsoft perspective, we are planning to offer additional tech talks that will deep dive into more of the theory, why we have these equations, how we use them, and then how we can go through different use cases of this functionality, specifically in Dynamics. Next, as I said, if you try to enable this all at once, it could have some big financial implications. So instead of doing that, we recommend that you prototype with a specific group of items or an item to test out how it works for your company. So you might pick low risk items like low cost, or smaller items that don't have as much storage capacity, and choose to test DDMRP on those. You might also just target 1 or 2 items where you stand to gain a lot from the lead time compression and shock absorption, and use that as your use case for DDMRP. Oftentimes, to verify how DDMRP is configured, that it's configured properly and it works for you, you can simulate, for example, your last 2 years of purchases if you had instead used DDMRP, and compare them to your actual purchases to look at whether DDMRP would have been effective in that case. You can just implement it. If you have the financials to support the potential fluctuations in inventory, you could just go and implement DDMRP throughout your entire product offering. But as I said, we recommend that you prototype, test it out, and play with the different factors and variables that are available to you to make sure that you have a model that supports your business appropriately to really get those benefits that we talk about from DDMRP. And then once it works, then we plan the rollout of the full implementation. For additional resources, the first one that's very important is the Demand-Driven Institute website. You can use this to find overviews on their different methodologies. You can find the training from there, as well as articles and white papers on DDMRP. We've also linked, the second link is a link to a video that's a short overview of what DDMRP is to help you maybe refresh on the concept. As Beatrice mentioned before, we really want to hear your feedback on this product. I've linked the Yammer group to the specific planning optimization group. So please let us know once you test it out, how it is, what your feedback is, and that will help us bring the best product that we can to you. I've also linked to a specific page on the Demand Driven Institute for the white papers and articles that you can download as resources that are really helpful to put even into more context what the theory of DDMRP is and how you can apply it and why we apply it this way. And of course, as always, if you have any feedback about the product, especially in the planning area that we're talking about, please provide us that as an idea on the ideas site. We've been focusing on reviewing that feedback and how many votes it has, and it helps us prioritize our roadmap to really help the community. There will be Microsoft Docs articles coming that walk through how to configure this functionality and have it all written out. They are not published yet, but they'll be here soon. With that, we will get back to our riddle of the day, which was, how do you organize a party in space? And the answer is, you plan it. So thanks for sticking through this tech talk and making it to the end. We will move over to our questions now and start walking through those.
So I'll answer the questions in the order of the session so we can go through them. First one from Hardik is the forward average daily usage based on forecast plus requirements or just forecast? It's based on the forecast only. Then next question from Andrea is, how do we define long, short, or medium lead time and variabilities? It's experience. Yes, partly. It will depend in your company what long lead time is, medium lead time is, and short lead time is. So you can take overall your items, see how is the lead time, and then make some ranges yourself. For example, between 2 and 10 days, we consider it's short. Between 10 and 20, we consider it's medium, and between 20 and 50, if you have a vendor overseas, that's long. But it will be specific for your company. And then you can always adapt them with experience. That's one of the points of DDMRP, is that it should be adapted. So you should evaluate the factors, how they affect. For example, if you have items with a lot of variability and you put a 0.8, so to say, that is high variability, you see it's not enough, then put a 0.9, then maybe put it to a 1. It's also part of the experience. Next question from here is also related to the variability. The variability is on the demand variability of the item. How the lead time varies is the lead time factor, and how the demand of the item varies is the variability factor. Next question from Steve is, are negative and positive days taken into consideration with the coverage code decoupling point? And the answer is no. With decoupling points, the way the planned orders are created is, as Anne was explaining before, whenever the net flow is below the reorder point, a planned order will be created with a quantity to fulfill up to the maximum, and it will always arrive one decoupled lead time into the future. That's what planning thinks. And if it doesn't exactly arrive one decoupled lead time into the future, that is meant to be absorbed by the buffer. So no concept of negative days and positive days. I'll take next one is should we keep indicating the coverage group for the item so it can be considered for other allocations not specified in the item coverage? Yes, it's your setup. So you set up the items as fits best your business. So if you have a product, like in this case, your pillow, that you always fulfill by period coverage, every week you supply for that period, keep doing that. And if you decide that it's strategic for your company, that in this specific site and this specific warehouse, the demand is more variable, you have shorter customer lead times, then you specify on the item coverage that for site 1 warehouse 11, as an example, you will have that as a decoupling point. So the same item in all the rest will just keep being used as the coverage code you use it.
I'll just point out in my example where I left it blank, I have a general coverage code set up in the master planning parameters. So wherever I don't have the specific decoupling point, it will use whatever I've set as the general coverage code.
Exactly. That's a good example as well. Next question is, does ADU take into account sales orders and such, or only forecasted demand? As we mentioned, forecasts only. And then there's a comment, I see this as extended functionality to coverage code min-max. Do you still see any scenario why you would use min-max functionality instead of DDMRP when procuring to stock? It's conceptually different. DDMRP has all this visualization, all these specific ways of replenishment, the buffers, so that overall it works. So it's not just replenishing min to max. You could establish, it's also part of the DDMRP methodology, that you could establish a buffer that is min-max. They are not often that used. So conceptually, it's different, I would say. It's not just a min-max buffer. Then next question from Al is, how do variability factors relate to C-score and standard deviation for demand and lead time? Is it possible to derive the variability factor from standard deviation? I honestly don't know. There's probably a way to do it, so they'll be probably correlated.
When I was doing the research, there's actually a good white paper on the DDI website, which talks about calculating the coefficient of variability for the demand for each of your items, and then using that to analyze the how you should group your items into low, medium, and high variability. So they do actually, I think, recommend calculating the coefficient of variation. But that won't be the factor. It will just help you figure out what the factor should be. And that's external to the system.
Thanks, Anne. As well, we have one from Andrea. How do you define how many days in the future to calculate the qualified demand? It's actually the time fence. It's what we use. Then next question is, if we set up a max order quantity, which is lower than the reorder quantity, DDMRP will generate multiple planned orders, I assume. Will those planned orders have different priority? No, they will not. It is the full quantity will have a priority, and then when it gets split into orders, they will have the same priority. You can use it with planning priority models, which will give different priorities, but let's not get deeper into it. How was the question from Alex? How was the spike threshold determined? Is it calculated or defined manually? It is a field on the item coverage, so it is defined manually. We've heard from some customers that they would like it to be automatically defined, as it is general rule as half of the minimum. So we'll be looking into adding that to our plans as a default, and then you can always override it. Then another question, is there any support to analyze if my item is in the right coverage group in regards to variability and lead time factors? No, there's not. But if you would like any functionality, any feedback, please write it on Yammer. We'll be actively looking for it and considering your feedback. Question from Andy, will planned orders be color-coded? They are not, but again, please write it as well. We'll consider it. Another question from Andy, is there a data entity for importing usage history from a customer's legacy ERP? Yes, there's an entity for importing the historical buffer values. Question from Craig, does it work with process manufacturing? Yes, there's nothing special in that sense. A couple of more in the last minutes. Yes, it can work with distribution. We'll be making a distribution case usage. It is different from priority-based planning, though. Answering another question, we'll be explaining more about this. How would production scheduling be done if a manufactured part is using DDMRP? Essentially, the planned orders are created the same way. Instead of the dates, it works by priority and when the orders are created. And with this, there's many more questions that we cannot answer, but please post on Yammer. I'll be looking at it and answering any questions.
And I think with this number of questions, we'll definitely do a live Q&A session, maybe after it's available for everybody to update in their sandbox, so we can answer more questions that way as well. Yeah. With that, I'll turn it back over to Peggy to wrap us up.
All right, wonderful. So if the attendees could have a look in the live event Q&A panel, we've posted a link to a short survey. We would love your feedback on today's session and hear what you'd like to see in future events. Thank you so much for your participation there. As a reminder, registrants will receive an email notification as soon as the recording is available. So a big thank you today to our attendees and our presenters. Have a great day or evening wherever you are.